So for this lecture, we'll briefly go over the different approaches used to fight wildfires. Firefighters often work 16 to 24-hour shifts. So I've also posted a link to a short video that follows 24-hour forest firefighters shift in California that gives a good glimpse of what they might be doing. This is a photo of the Thomas Crown Fire in 2017. Along the ridge, you can see a non-natural looking area that is bare vegetation. This is a fire break or a fire line. The whole idea is to create an area without fuel so that the fire will die out. Based on the fire triangle, fuel is the most accessible thing to manage. So most wildland firefighting approaches involve reducing fuel. Here are the Big Bear hotshots, which is what wildfire forest teams are called. They're in Yosemite in July 2018 working on a fire. You can see the fire isn't that close, right? But it's reasonably close. And the goal here is to remove the fuel so that the fire cannot be advanced beyond this point, presuming it would come in this direction. Equipment can also be used to make fire breaks. And in addition to just physically removing the fuel, small fires can be set. These are called backburns. Backburns are basically designed to burn out all the fuel before a major fire arrives. They are set along the fire break containment lines, and only when weather conditions mean that the fire danger at that particular site is low. You can see that the person is lighting fires along this side of the fire break, but the other side of the fire break has actually already got burned areas on it from already doing a backburn on that side. There can be some negative ecological effects to backburns, such as trapping animals that would otherwise flee the major fire or burning sensitive plants. Retardant is an approach that is used in remote locations where firefighters can't get access. It isn't dropped directly on the fires, but instead in advance of the fire, similar to the way a fire line might be built. It makes it harder for the fuel to combust. The goal is to buy more time for firefighters to create more robust fire breaks. The addition of the red colorant is used to fight wildfires because it enables air tankers to see where the retardant has already been applied and where the next drop is needed. Two of the main ingredients in this type of fire retardant are sulfate and phosphate. These can also be found in fertilizers, and while they are relatively safe for humans and forests, they can have negative consequences for freshwater systems like lakes and streams. Other specially designed planes and helicopters can drop just water. Some of these can refill using hoses or buckets from nearby water sources, such as lakes or swimming pools, so that they don't actually have to return all the way to the airport. On the helicopter on the right here was just purchased by San Diego to start replacing some of its helicopters for firefighting, and it cost $20 million. In places that cannot be protected adequately by fire breaks, there are some extra options for buildings in particular that are historic and might require protection. There are only 8 ranger stations from the early Forest Service period in the Pacific Northwest that are still in existence. This cabin is one of them. It was built in 1909, and it was the office for the Mount Adams District, and it's the oldest building within the Gifford-Pinchot National Forest. There have been relatively few alterations to the property over time, and the majority of the architectural fabric is original. The Forest Service uses special aluminized structure wrap to protect structures like these stations at times when it is not possible to stay and physically fight off flames or embers. This is the building wrapped up for the Cougar Creek fire in 2015. This was the 3rd time since 2008 that officials have used the wrap to protect the structure. The wrap goes around everything from the porch steps and up, and is similar to the material used in the fire shields that the firefighters carry with them. It is said to reflect up to 95% of the radiant heat and also features a cloth lining. Wildfires are dangerous. Between 2000 and 2019, 400 wildland firefighter deaths occurred. In 2013, a major tragedy struck the wildfire fighting community. 19 men fighting the Yarnell fire became trapped and overrun by the fire. The movie, Only the Brave, is based on the story of what happened. In watching through these slides, it may have occurred to you that the main goal of many firefighting activities, reducing fuel, is actually something that we could do before a fire even starts. We actually do a fair amount of this. For example, fire breaks can be maintained through forests, in some case also acting as road systems. We also use controlled burns as a way to reduce the fuel load in forests. The fire burns the surface and the ladder fuels, making future intense wildfires less likely. This image is an example of a controlled burn in Australia, and you can see also how well the fire lines keep the burn within their boundaries. There are multiple benefits to controlled burns, including decreasing invasive species. Controlled burns are also called prescribed burns, and many conditions must be met before a prescribed fire can be ignited. The date chosen must be a combination of the correct humidity, wind speed and direction, temperature, fuel moisture, and atmospheric conditions. Factoring in all these requirements limits the number of days in which a prescribed fire can take place. They're scheduled for times when the weather conditions are safe so that the fire will not burn out of control. In this image, you can see that the vegetation is fairly green, for example, and not dry, decreasing the likelihood that the fire will get very hot. Prescribed fire is one of the most effective tools that we have for preventing wildfires and managing the intensity and spread of these fires. So what did we cover in this short mini lecture? We basically have talked about some of the main strategies for maintaining forests and for fighting wildfires. And those include fire breaks, burnouts and backburns, airdrops of retardant and water, protecting buildings from radiant heat, and using proactive approaches that make intense wildfires less likely to happen in the future.